How are steel coils loaded on ships? It is not wrong to say that steel is one of the primary foundations of the global economy. Steel is utilized in diverse forms for countless purposes ranging from industrial to agricultural, domestic to urban, and infrastructural to product-based. Steel and various steel products are crucial elements in global trade and play a pivotal role in the economic growth of any nation. After extraction of hot steel from blast furnaces in steel furnaces, the steel is cold hardened and processed further to improve strength, quality and other surface and internal material properties. After that, it is shaped or molded into slabs, ingots, sheets, billets, etc., for further utilization. After the early stages of steel production, there are two kinds of rolling processes in a steel rolling mill. The hardened steel in the raw or semi-processed form is then cast into different forms. Hot rolling. Cold rolling. In hot rolling, the steel is heated to very high temperatures, till red hot, and rolled. In cold rolling, the steel is cooled off rapidly and is treated at low temperatures to improve surface and mechanical properties. After cold rolling, steel is ready for utilization from a material point of view. After partial processing of bulk steel after hot rolling or complete processing of steel after cold rolling, the steel is often wound up and rolled up into large coils for convenient transport and storage. A coil of steel composed of a hot-rolled or semi-processed steel coil is known as a hot-rolled coil, and this needs to be further treated and cold-rolled for usage. Similarly, a coil of steel made up of cold-hardened and rolled or fully processed steel is known as a cold-rolled coil. Most of this steel is carried in cargo vessels as steel coils for convenience. But specific regulations and guidelines are abiding by which the proper stowage and transport of these coils in large quantities are carried out in ships. Loading steel coils on ships. These steel coils are usually shipped in bulk and stowed accordingly onto the vessel's designated cargo holds. These steel coils weigh around 40 to 50 tons. So, before loading, it must be ascertained that the holds are swept, cleaned with fresh water and dried thoroughly. Pre-loading surveys of the steel coils are essential. Assessing the integrity and watertightness of the cargo hold, the integrity of the hatches and openings, and ventilation and loading cranage systems. A thorough inspection of the cargo holds and carefully marking sharp edges or points. Ascertaining the presence of loading and securing manuals with a suitable loading plan. Loading and unloading procedure. The loading process is carried out meticulously with the help of cranes and derricks, both on board and those present in the cargo terminals or ports. The coils are usually lifted through the geometric center, where the suspension point is typically braided steel wire wraps or slings. Tying chains are avoided to prevent damage to the steel surface. A maximum level of care is taken to ensure that the coils remain unharmed and are unscathed on their surfaces, especially cold-rolled and finished ones. When these coils are handled using forklifts, round or circular lifting section tines are used as conventional rectangular ones with sharp edges, which can harm steel surfaces or distort the coil center. Coils are always placed such that they are axially oriented with the longitudinal direction of the ship. That is, their circular centroid always faces the fore-aft direction of the vessel. They are permanently wedged at the bottom in a transverse direction to prevent rolling motions and damage. To avoid damage to the steel surface and ensure sufficient friction to stop the coils from rolling, they are usually placed on wooden planks arranged in the transverse direction, known as dunnages. They are usually about 25 to 30 mm thick and act as an intermediate layer between the coils and the ship's plating. Furthermore, they can absorb a significant amount of the structural loads from the coils before they are uniformly distributed over the vessel's structure. These dunnages are carefully dried beforehand to ensure that any form of moisture that can pose a risk of causing rusting and corrosion to the steel coils are absent. For all practical purposes, the loading coils are always placed in designated cargo holds and never on the deck or any other part above the strength deck. The loading is done accordingly to ensure optimal space utilization but not abnormal or non-uniform loading of the coils. Furthermore, the dunnages are also carefully placed in a way such that the weight of these coils is not transferred to unstiffened spans of the plating. On the flip side, this is problematic as this causes the overall loading to not comply with the loading information specified in the information and cargo guidance manuals. But for all practical purposes, the steel coils are usually carried on large bulkers or other general-purpose carriers that are adequately strengthened and have high design load values. Similarly, during unloading, the wedges and lashings are all unlocked carefully, and the coils are lifted by cranage equipment one by one, starting from the topmost layer in a fashion similar to that of loading. Stowage and securing. After loading the steel coils, stowage and securing is another essential aspect. Steel coils vary in size and weight. So, from the first principles, their stowage philosophy is the same as any other form of cargo. They are stowed in the lower holds and loaded from bottom to top for a more significant number of such oils. To keep the center of gravity below feasible limits of vertical position, the heavier coils are loaded first and kept at the bottom regions, and the lighter or smaller ones at the top. The coils are strapped or banded to one another using suitable securing arrangements. They are positioned in athwartships and in multiple tiers or levels for a greater number of coils. Between two successive layers, the coils are strapped to each other. For multiple rows of coils stowed, there is a minimum clearance of 4 to 6 inches between two rows to avoid contact forces and any damage during loading and unloading procedures. A central coil, also known as the key coil, is chosen in a central location both in a horizontal and vertical sense, with steel strappings directed to both the adjacent and the steel coils situated below. The strappings are hard metallic, are in taut conditions, and are often pneumatic in modern arrangements. Any key coil resting on a bottom layer of coils is lashed and positioned. The bottom edge of the diameter is below the top tip of the bottom coil by at least 1/3 of the geometric diameter of the latter. However, it should not exceed 60% of the diameter of the top or key coil. Thank you all for joining me in this exciting journey today. We've explored a fascinating topic and learned so much along the way. So, stay curious, keep learning, and until next time, take care and happy exploring. Signing off.